Hello everyone, my name is Alexa Takahashi and this is my poster presentation for the IMCR 2024 Congress, which is entitled NiTi-Nb xHA Composites Fabricated by SPS Study of the Properties and Bioactivity. And well, NiTi alloy belongs to the shape memory alloys used composed of a binary and equiatomic or near equiatomic system. In its properties such as superelasticity, shape memory, and good corrosion resistance and biocompatibility make it attractive for the use in biomedical applications. And it has moderate solubility with different elements, which is why niobium addition to the matrix has been studied and have improved some of its properties. Also, integration has become a topic of high interest for materials used as bone implants, so we propose to add a bioactive ceramic such as hydroxyapatite to the NiTi alloy to improve its reactivity and study the change in its properties. A composition of 97 NiTi and 3 niobium atomic percentage was used for the matrix, and different amounts of xHA were added in 1, 3, 5, and 10% by volume. And in contrast to other studies, no mechanical alloying was performed, only the powders were mixed in a flask for 10 minutes. The samples were then sintered by spark plasma sintering method, which used pressure and temperature simultaneously. A pressure of 400 megapascals, a heating ramp of 100 degrees per minute, and a sintering temperature of 1000 degrees were used, plus a holding time of 5 minutes was added. And for the characterization of the samples were cut cross-sectionally, and then the surface of all samples was rugged with different grades of sandpapers with 90 degrees turns when changing the sandpaper, and subsequently 3, 1, and 0.05 alumina were used to leave a mirror finish, and which was finally etched with a solution based on the STM norm. Photographs of the target samples were taken with an optical microscope, accompanied by SEM image and ADS to corroborate what was observed under microscope, and for the study of the crystalline structure, XRD analyses were used, and the mechanical properties were studied by using Vickers microhardness with 15-gram forms used. And finally, corrosion tests were conducted using a 3-electrode electrochemical cell connected to a potentiostat, performing potentiodynamic sweeps. And for the results, we observe in figure 9 the image obtained by the optical microscope, and there is the presence of grains distinct from the NiTi matrix that are associated with the niobium particles, and a microstructure with equiaxed grain is also observed, which can be related to the type of sintering used. As HA is added, a change within the grain is observed. With the presence of a needle-like structure becomes more apparent at higher percentage of HA. And in the image obtained from backscattering electrons, a light tone observed for the niobium particles of the surface of the sample, while a dark tone is seen for the NiTi matrix, and according to the EDS analysis, is close to equiatomic. And when analyzing the sample with a higher amount of HA, we can observe the same change in microstructure as in the previous image. These needles are related to an intermetallic component of NiTi according to the literature, which is formed by a nickel-rich composition. The diffraction pattern shown in figure 10 contains some of the identified phases, such as the B2 austenitic phase of NiTi and its B19 prime matricitic phase, which are important for its shape, memory, and superelasticity properties. Additionally, we confirm the presence of the intermetallic that we see in SEM, which increases as the amount of the HA increases. And some phases are also observed that may indicate some decomposition of HA, such as calcium titanate and calcium oxide. But however, at 10%, some peaks belonging to the signal of poor HA can be detected. And in figure 11, the hardness values obtained by microindentation are observed, ranging in from 300 to approximately 700 Becquerels, increasing almost linearly with the addition of HA. This may be related to the intermetallic that we found, which tends to harden the material as it is a metastable phase that induces internal stress. And the OCP values are shown in figure 13. An increase in the open secret potential is observed for the samples with 3 and 5% of HA, and this increase may be associated with the samples having a greater passivity or as an indicator of stability under the specific condition used. For the potential dynamic sweeps, the curves shown in figure 14 were obtained. The behavior of the samples appears relatively similar at first glance. However, the TOEFL extrapolation method was used to obtain the current density values and calculate their corrosion resistance, and the corrosion rate was calculated according to the ASTM G10289 standard, and with the lowest value observed for the 5HA sample, which is 0.0007 millimeters per year. And well, the conclusions are the SPS method proved to be functional for this type of alloys or composites, and we promoted an equiaccelerated grain growth, and the presence of two NiTi phases were detected, as well as NiTi intermetallic and some decomposition phases of the HA. And we confirmed the Ni4T3 intermetallic was also detected by backscattering electron imaging. Well, the addition of HA affected the mechanical properties of the material, with an increase in hardness values above 300 Becquerels for the 10% sample, above the NiTi sample without any addition of HA. And well, samples with intermediate H values were more resistant to corrosion, giving corrosion rates of approximately 0.001 millimeters per year. And this is all for my part, and thank you for listening.